A new asteroid has been discovered that comes uncomfortably close to Earth. 2 missions are going to be passing very close to the tail of 3I Atlas. A new shakeup in NASA's Artemis III plans, and Webb sees a giant star before it goes supernova. All this and more in this week's Space Bites. We now know of about 1 million asteroids in the solar system, and that number is set to increase dramatically when Vera comes online. And the kinds of asteroids that we are most concerned with are the ones that can cross the Earth's orbit, the near-Earth asteroids. And there are several classes of asteroids, but one that is the most concerning are known as the Hera asteroids. And these are ones that have their entire orbit that is inside the Earth's orbit. And in fact, these are very rare. Only 39 of these objects have ever been found. But these objects are really hard to find, and that's because they orbit close to the sun from our perspective. They are always inside the Earth's orbit, and so they're often lost in the glare of the sun. And most recently, astronomers have found another object, designated 2025 SC79. And it is not a small object. It is 700 meters across and comes relatively close to the Earth every few months. And the discovery was made with the dark energy camera on the National Science Foundation's Blanco 4-meter telescope. And this is a telescope that is doing a survey for exactly these kinds of asteroids. And so there is no expectation that this asteroid is going to collide with the Earth, just that a very large asteroid that comes very close to the Earth was unknown up until this point. And this shows that even though we have tremendous asteroid capability to be able to search for objects that are across the solar system from our perspective here on Earth, it's the ones that are very close to the sun from our perspective that we can't see, that we need space missions that can observe asteroids from a different vantage point to be able to show us asteroids that we were previously unaware of. And if you want to read more about this, we've got a story from Evan Goff on Universe Today. All right, some more Comet 3 Atlas news. Now, this object is passing through the solar system very quickly, and it is leaving a tail behind it, the way comets do. But then the particles in the comet are interacting with the sun's solar wind, which causes them to spread out and be pushed away from the object. And in an amazing coincidence, 2 space missions that are currently on their way to their destinations are going to be passing relatively close to the comet tail and maybe even pass within it. Hera is a mission from the European Space Agency that's being sent to check out the aftermath of the DART mission that crashed into asteroid Dimorphos. The second mission is NASA's Europa Clipper, which is on its way out to Jupiter and to be able to make regular observations of its large moon Europa. Both of these missions are going to pass downwind of the tail and probably come within at least 8 million kilometers of the tail particles. That's close enough that they should be able to detect the presence of ions in the tail caused by this interaction with the solar wind. Now, the Hera spacecraft doesn't have a lot of great instruments for this kind of work, but the Europa Clipper has exactly what it needs on board. It has a plasma instrument and a magnetometer that should be able to detect the ions and magnetic field changes. But the scientists working with these missions don't have a lot of time. They've got to be able to come up with a science plan and be able to test it out and get ready to be able to make those observations when the spacecraft come at their closest point to the tail, which is going to be in just a couple of months. If you want more information, we've got a story by Andy Thomaswick on Universe Today. And this is on top of something that we reported in a previous video, that the JWST mission might be well positioned to be able to see the tail as well. So we've got a video that covers all of the science details known about Comet 3A Atlas so far. I'll put a link in the show notes. Now let's talk about the Artemis missions. Now here we are, late 2025. Just a few months away, we're going to see the Artemis II mission lift off, which will be a recreation of the Apollo 8 mission, where a team of 4 astronauts are going to do a flyby of the moon on a space launch system. But what comes next, theoretically, is Artemis III, where a mission takes astronauts down to the surface of the moon and brings them home again. And this is going to require a completely different architecture than what's happening with the Artemis II mission. SpaceX has been awarded a contract to build the Human Landing System, which is a modified version of the SpaceX Starship. It's going to be sent to the moon, and it's going to serve as the lunar lander that will carry the astronauts down to the surface of the moon and then back up to space. The problem is that Starship is behind schedule, and so far behind schedule that it's clear that Artemis III isn't going to meet its 2027 deadline for bringing humans to the moon. And recently we got some confirmation that something needs to be changed. There's going to be a shakeup. And this came from Sean Duffy, who is the acting administrator for NASA. In a recent interview, he said that they're now looking at new options for how to get astronauts down to the surface of the moon. And they've got a bunch of options, but none of them are great. One option is to use a landing system being developed by Blue Origin called Blue Moon Lander. And this was originally going to be an uncrewed vehicle to bring cargo to the moon. And so they could use a variant that can carry humans and cargo down to the surface of the moon. And this is very different from the one that's being planned for the Artemis V mission. That'll be a much larger one. So they're proposing using the Mark I version, which is smaller, more like the lunar lander in the Apollo missions. But then we've also seen that Lockheed Martin has put their hat into the ring and said that they will be capable of building a lunar lander. And then another possibility is just having the lunar lander built within house at NASA to fulfill that 2-ish year timeline to be able to get ready for a lunar landing. And one of the problems with the Lockheed Martin option is that it would probably be cost plus. So while NASA has contracted SpaceX for about $2.6 billion, about $3.2 billion going to Blue Origin, the Lockheed Martin one could be $20 billion plus to deliver humans to the surface of the moon. So this is a bit of a mess. And so we don't really know how everything is going to proceed. And of course, this is also happening during a time of the government shutdown, during a time when you've got tension between Elon Musk and the White House administration. You're also seeing huge numbers of layoffs at NASA. You're seeing disagreements in the budget that NASA is going to be getting. You've got that the White House wants to cancel the Lunar Gateway. So we really, right now, we just have no idea what's going to happen. At least now it's nice to see this being admitted by the administration, and then that will prepare us for the chaos that's about to happen. We've got a story that goes into all the details from Matt Williams. And I'm going to give you a longer, more opinionated rant at the end of this episode if you want to stick around for that. For astronomers, anything heavier than hydrogen and helium is considered a metal. And so then when astronomers measure the amount of heavier elements in a star or galaxy or planet, they measure its metallicity. How much metal is in that object? You get metal through the process of nucleosynthesis, where lighter elements like hydrogen, helium, are fused together in a variety of ways into these heavier elements. And through multiple generations of stars, you get more and more metals. A modern habitable terrestrial planet like the Earth is the result of previous generations of stars living and dying, blowing off their materials, neutron stars colliding into each other, giant stars going supernova, and all of this coming together to form a planet with larger amounts of metal. And according to new research, the density of planets that you can get in a star system increases over time, as well as the actual radius of those planets coming down. And it takes several billion years before you can get planets that are as dense and contain the kinds of raw material that you can have life like a place like Earth as we know it. And so according to a new paper, researchers found that the iron to magnesium and the carbon to oxygen ratios rapidly decrease between 2 and 6 billion years. And the amount of iron that's available doubles between 1 and 5 billion years. And what makes this really interesting is the amounts of these metals, yes, even oxygen is a metal, are available to planets at different times throughout the galaxy's history. And so different galaxies can have different rates of habitability depending on how long they've been in operation and how many generations of stars have come and gone to be able to create the more modern planets that they have. We've got a story about this by Evan Goff. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was a squeaker that DNA could survive in Martian ice for millions of years protected from the radiation. It just beat the launch of Starship 11 by 1%. So thank you everybody who voted. Now we're going to put the new vote into the post tab for this exact show. And then next week we will celebrate the winner. So the best chance to see it, subscribe to the channel, click on the notifications bell, go into the post tab and then just vote for a bunch of the past weeks. And then that will remind YouTube that you want to see this in your feed. All right, let's talk about dark matter. Now, dark matter is, of course, this invisible material that seems to be the vast majority of the matter in the universe, where you have the stars, the galaxies, the gas, the dust, the things we can see. Dark matter probably outnumbers that by a ratio of about 5 to 1. It's everywhere. It's the most massive stuff, and yet it's invisible. And that's because it really has two properties. One property is that it has mass, and that does affect the movement of light. It does affect the movement of galaxies and stars and all of that. The dark matter is out there influencing us, but it is invisible. It doesn't interact with electromagnetic radiation in any way, probably. And we have an example of a dark matter that was discovered, which is neutrinos. These are particles that are streaming out of the sun. They come from supernova. They come from supermassive black holes. They are moving at close to the speed of light. They don't interact with regular matter. They don't interact with electromagnetic radiation, but they do have gravity. So this idea, like I know a lot of people feel like dark matter is like such a weird idea, but we have neutrinos. They do most of that. But the trick is that neutrinos are considered hot dark matter. They move at close to the speed of light. And that model doesn't work for the behavior of the large amounts of dark matter that we see. It's assumed that dark matter is cold and moves slowly, and that the most widely accepted idea is called weakly interacting massive particles, or WIMPs. And again, we don't see this cold dark matter interacting, but maybe it does. And if it does, then astronomers think that it would give off some faint glow of radiation through its interactions and annihilation. But this has never been seen directly. But a new paper proposes that you may not be able to see this radiation directly, but you might be able to see what happens to light that passes through regions of dark matter that are interacting and annihilating with itself. If the dark matter doesn't interact with itself, then as the light passes through it, it will be shifted into the blue. It's essentially interacting with the gravity of the dark matter, and then that shifts it into the blue of the spectrum. The light will turn more blue. But if the dark matter is weakly interacting, then the light will be shifted into the red. And so you would see a difference in color, whether light is a little bit more blue or a little bit more red, where it's passing through regions of dark matter. And it all depends on whether that dark matter is interacting. So this kind of observation should be possible with the current generation of telescopes, or telescopes that are going to be available in the near future. We've got a story about this from Dr. Brian Koberlein. Astronomers have known about an extreme black hole system. You've got one supermassive black hole with about 150 million times the mass of the sun, and it is orbiting around a black hole with 18.35 billion times the mass of the sun. So it's like a planet going around a star, but the star has 18 billion solar masses and the planet has 150 million solar masses. But it gets even weirder because there's an accretion disk around the larger supermassive black hole. And so the smaller black hole, and I say this like hilariously, right? Like 150 million times the mass of the sun, that is so much bigger than the black hole in the Milky Way. It's bigger than the one that's in Andromeda. This black hole is on an elliptical path that takes it through the accretion disk around the bigger black hole and then back out again. And it causes two flashes that are detectable. And now astronomers have been able to detect these flashes coming through the accretion disk and determined that it takes about 12 years for this smaller black hole. And still, it's hilarious when I say smaller black hole as it passes through the accretion disk of the larger black hole. And what this shows is you can actually have two supermassive black holes that are together inside a quasar, which of course is an actively feeding supermassive black hole. And so it could be that there are many more of these out there. We've got a story about this from Matt Williams. When a massive star reaches the end of its life, it can explode as a supernova. And the classic example of this is something like Betelgeuse, where you've got a star that has about close to 20 times the mass of the sun. It's a red supergiant. It's going to live somewhere between dying tomorrow and, a million years from now. So these events happen very rare, and yet it's expected that these red supergiant supernova are one of the most common kinds of supernova that are out there, but they haven't seen them as often as people were expecting. But they happen occasionally within various galaxies, like once a century or so. And so you never know which of these stars is actually going to be the one that's going to detonate. But now astronomers have been super lucky. They found a new supernova, and then they went back through archival data from James Webb and from the Hubble Space Telescope, and they found the precursor star. And what they found was very interesting. The supernova went off in galaxy NGC 1637, which is about 40 million light years away. And the supernova is designated 2025 PHT. The star had about 100,000 times the luminosity of the sun, but it was enshrouded in this field of dust. Probably it had been pumping out a lot of dust near the end of its life. And so it was 100 times optically dimmer than it would normally be. But thanks to James Webb, which has its infrared instruments, it was able to pick out and analyze the star so that astronomers were able to understand the object before it exploded. And then when the supernova went off, they were then able to compare what the star looked like before to the expanding wreckage of the explosion. And like I said, they also had it in archival Hubble Space Telescope data as well. And this is like a preview of what we're going to see with the upcoming Nancy Grace Roman telescope, which is probably going to find hundreds of these objects before they explode as supernova. We've got a story about this from Evan Goff. Did you see ads at the beginning of this video? That's because YouTube won't let us remove the ads from our videos. Now, we don't put any ads in the middle of our videos, none at the end of our video, but we are not able to remove them from the beginning. But there's a place where we can put them with no ads, and that's over on Patreon. We release a longer version of every single one of our videos because I think it's a better experience for the user. So if you want, I'll put a link in the show notes. You can go over to Patreon, you can watch this exact same video and get one additional story and enjoy no ads. It's all completely for free. I'll put a link in the show notes. And this week's bonus story is how researchers are still discovering new insights about the moon thanks to the Apollo samples. Like, I know you're worried, like, you're gonna have to pay for this? No, it's totally free. You don't have to be logged in. You don't have to be a patron. You can just watch that exact same video over there with no ads. But if you want even more space coverage, we write a ton of additional stories over on Universe Today. We cover between 30 and 40 space news stories every week. For example, Starship could cut the travel time to Uranus in half. How alien civilizations may only be detectable for a cosmic blink of the eye, and how the winds on Mars are stronger than we thought. Now, I sit down and gather all of these stories up into my weekly email newsletter. I write every word of it. There's no ads. It's completely free. And if you want to get it, you can go to universetoday.com/newsletter. All right. Those were all of the stories that we had this week. Now I'm going to rant a little bit more about the upcoming Artemis III mission. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bielek, Cy Nielsen, Dark Finga, Dave Veribaff, David Giltonen, David Matz, Evan Pro, Greg Veely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, OneStepForAnimals.org, Paul Robach, Brent Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So this whole situation with Artemis III feels like a bit of a mess. The problem is that there are all of these separate issues that are all uniquely messy. Everything is very chaotic right now. So, for example, Artemis III was supposed to originally launch in 2024. That was pushed back to 2025, 2026. Now it's 2027. Even Sean Duffy is admitting that that's probably not going to happen. That means it's going to be delayed a couple of years. That the Starship launches, although they are proceeding, we still haven't seen that next stage Starship that's capable of going to space and returning and being captured. We have not seen the tests of propellant transfer and storage done in space. We haven't seen the human landing system version of Starship, the one that's supposed to go to the moon. We haven't seen a test landing. Like, there's a lot of things that have to be done. It's going to be between 15 to 20 launches of Starship just to be able to carry enough fuel to be able to take it to the moon. Although Blue Origin is working on its version of the lander. I mean, the joke is about Blue Origin's rockets. We've only seen one disposable test of a Blue Origin New Glenn rocket so far. We haven't seen any of the reusable capability. We don't know the state of their lunar lander. We don't know about the state of their Mark I lunar lander. Lockheed Martin is putting their hat into the ring now. We don't know what this is going to cost, what this is going to take, how far along they are. Could NASA develop a lunar lander in-house in 2.5 years, considering they've had thousands of people get laid off, that right now everyone is furloughed and back at home, that the White House administration has called for the cancellation of the Lunar Gateway, that, everything is a mess. And yet, I think what we're seeing is this drive to beat the Chinese, because we're not seeing that kind of a mess from the Chinese Space Agency. They are proceeding through their timelines. They are sending their missions. They're on schedule. And the plan is in 2030, they're going to send just 2 giant rockets to the moon, one with the lunar lander, one with the capsule that's going to carry the astronauts. They're going to get into the lander. It's going to go down to the surface of the moon, come back up, and then they're going to come home. And then they're going to work on building on their lunar infrastructure. And so what it really feels like is that it's turning into a race, which it isn't a race, because the Americans already landed on the moon 50 years ago. So why recreate the Apollo missions? And that's what feels like starting to happen, is that you're moving back to, let's just send a lander, some people get out, they take some pictures, collect some samples, get in the lander, and come home. That's a thing the US already did 50 years ago. The dream of Artemis was to build a more sustainable presence in space, to send the Lunar Gateway, which would be this halfway point between the Earth and the moon, energetically, that you would then use potentially reusable rockets to carry people from the Earth to the Lunar Gateway. And then you would have some kind of reusable system, a ferry, that would be able to carry people from the gateway down to the surface of the moon. And then you could be sending cargo, you could be sending people, that you would have this bridge, and you could create a larger and larger presence on the surface of the moon. And until you actually build that, until you commit to that plan, it's always just going to be boots on the ground, and then people are going to come home, and then people are going to say that was too expensive, and then the missions are going to get canceled, and then we're back to square one. And it's really frustrating to me as a space journalist, because I want to be able to provide you some level of clarity about what's going to happen, when it's going to happen, what are people saying, but we don't know what's going to happen. We don't know when it's going to happen. We don't even know what people are saying. It is a mess right now. A lunar mission is hard enough on its own when everybody is moving together in exactly the same direction. It is orders of magnitude more difficult when nobody really knows what the plan is, that different groups are competing for contracts, that there are different narratives that are being said, and you've got a potential race with another nation, which is going to cause people to cut corners and start to abandon some of the core ideas of the mission. So it's frustrating right now, and I will try to keep you posted as we learn anything as the future unfolds. All right, we'll see you next time.